Now let's talk about a specific case of an Atwood's machine where the pulley itself has mass. In this scenario, we will still have a pulley and two masses M1 and M2. But in our situation now, the pulley itself will also have a mass, which I'm going to call MP. To make life easier, let's just consider the frictionless case first. So in this case, first of all, I'm going to assume mass 1 is greater than mass 2. And our coordinate system is X and Y. And then it goes over the pulley. So it will be X and Y, pointing this way. So first of all, as always, we will start with the Newtonian way. In our Newtonian mechanics method, how many masses will we have? We will have mass 1, we will have mass 2, and we will have pulley mass. So let's write the force equations for each of them. Let's write the force equation for each of them. For mass 1, the force equation will be sigma Fx equals T minus M1g, where T points upwards and M1g points downwards. For mass 2, it will be Fx2 equals minus T plus M1g, because the tensions will point again upwards. So let me put a subscript T1 and T2 for now. Now the pulley does cause a force, but that force is causing a rotational motion. So for that equation of motion will become sigma torque equals torque 1, torque 2. Now, if I look at this pulley here, my M1 is causing what kind of a torque? Counterclockwise torque. So counterclockwise torques are positive, and M2 is causing a clockwise torque, and clockwise torques are negative. So now from these equations, what is sigma Fx1? If M1 is greater than M2, then sigma Fx1 will be negative M1a. Sigma Fx2 will be negative M2a. So what is sigma torque? I alpha negative, which means I can rewrite each of these equations as minus M1a equals T1 minus M1g. I can write this expression as minus M2a equals minus T2 plus M1g, M2g, plus M2g. And I can rewrite this expression as minus I alpha equals, what is torque 1? R times F, which is due to tension 1, minus R times T2, which is tension due to mass 2. Now I know that alpha equals A over R. So I can just plug that value up here. Will equation 3 reduce down to minus I over RA equals T1 minus T2, R common out here. I can rewrite this over here to give me R squared. So this becomes minus I over R squared A equals T1 minus T2. I can rewrite all of these equations as minus M1A equals T1 minus M1G minus M2A equals minus T2 plus M2G and minus I over R squared A equals T1 minus T2. I know T1 equals T2, so that means I can add all three equations to give me minus M1 plus M2 plus I over R squared A equal minus M1 plus M2 G, knowing T1 equals T2, which means I can rewrite A as M1 minus M2 divided by M1 plus M2 plus I over R squared G. That is the expression for the acceleration.